Great pleasure to be here. First time for me, thank you. My name is Erik Brandsma. I'm the Director General for the Swedish Energy Agency. And I thought with the Volvo Ocean Race being around, I stick to that theme and talk a bit about ships. Two types, leadership and partnership. At the agency, we are about close to 400 people. In Sweden, we have quite a sort of a unique possibility to drive issues forward. We have, of course, policy analysis and development that we work with. We work on climate issues. We work on energy efficiency. We manage a number of instruments like the renewable certificate schemes. But we have in particular a research and innovation task from the government and use about 1.3 billion, 1.4 billion Swedish crowns a year to drive development towards a more sustainable energy system. Here we work with universities, of course, and with many examples of that. And here in Gothenburg, Chalmers is one of those universities, but they're well spread over Sweden. But we also increasingly work with the private sector, branch organizations, private sector, and work from, say, the whole chain of research and innovation, from basic research to commercialization. And there, of course, from 100% financing to 25 or even less % financing, depending on how the project works out. But these partnerships are actually key. And I'll get back to you on an example here. In the meantime, I'll give you something to rest your eyes on in case you get tired of me. I'll get back to you what that is also. But the energy sector is quite and I worked in it, in the private sector, in a number of energy companies, is not the most agile sector, one could say. And developments have been faster on the outside of the sector than on the inside of the sector, and hence we have a situation where large energy companies are looking for new business models. They've lost, in some cases, or in most cases over half, but in some cases over 2/3 to 3/4 of their share value over the past years. And there's a number of reasons for that. It's the rate of change I talked about. We had the financial crisis, of course. Profitability went down. We have seen Fukushima, the nuclear disaster there. We have seen the shale gas revolution in the US, that also contributed to that. Meant cheap coal coming in Europe, and a collapsed CO2 emission trading system in Europe. We also seen a quick and rapid change in the renewables industry. So the costs went down very quickly. And this package does something to a sector that reads a complete transition. Here we have to reevaluate how we're going to continue there. And change here is the new normal. Here, suddenly, we're in an environment operating where we see completely new business ideas. We see new actors coming in. We see new technologies being developed also quite quickly. And here's one of those. Yeah? Wasn't too long ago that we said, for example, the aircraft industry, flying, will never be possible without fossil fuels. Right now we have an experimental plane, the Solar Impulse 2, flying around the world without a single drop of fuel. Pure solar panels that make that possible in a combination with batteries. So currently they're trying to make the sort of the start for the crossing from Japan to Hawaii. It's going to take about 5 days or something. And it flies during the night and during the day. Now, these are the kinds of things that are happening due to certain leadership that pushes the agenda forward and creates a drive into a number of technologies which are very interesting to follow. We've seen other examples of that in terms of how grids are being built up, which HVDC lines, sort of direct current, high voltage lines. The talked about the battery example from Tesla. Suddenly the batteries are moving into our homes also. What does that? Other sort of more digital information companies moving into the energy sector. Very exciting developments, and I think that sort of this example of a number of companies that get together and try to fly shows how important that leadership and partnership aspect is in pushing development forward. Another example of that is the electricity bus system that we built up in Gothenburg, and that's pushing this rapid bus transfer line, which is unique in Europe, but also on top of that has it fully electrified. And I think it's one of those partnerships where we, together with Volvo and a number of other partners in the city of Gothenburg, for example, made that possible. And I don't think any of us alone could have made that possible. But it also provides leadership. I mean, CEOs, managers, we have to understand how important it is to believe in something and push that forward. A negative example is that, for example, very interesting, that you all remember this company Kodak? Yeah? You remember it because it's not there anymore. But the person that invented the digital camera was an employee at Kodak. But imagine that person going up to the board and say, listen here, I've got a whole new idea. But these developments, they're hard to stop. And I will get into your area also. When we talk about construction, and when we look at the systems that we have in Sweden, because let's start there, that's where I work and come from. In Sweden, the climate issue is a transport issue, because we have an energy system that's basically built up out of sort of biomass, water, and nuclear. So climate is transport. Now, if we try to separate out what does construction contribute to this challenge, it's very difficult to put your finger on it. And somebody this morning also tried to give some figures there. But the CO2 emissions from the construction machines, the working machines, are invisibly sort of spread out of a number of other sectors and not included in the statistics of the transport sector. So you would find them in the statistics of the construction sector, the agricultural sector, the mining sector, and a number of other industries. But if we just try to get an order of magnitude, I think we looked at numbers for 2010, and you looked at the equipment that's on the road or in the fields or in the quarries, we see that in terms of energy and energy use, the private cars in Sweden use 55 terawatt hours. Trucks have 19 terawatt hours. Buses, 3.7 terawatt hours. And sort of construction equipment, working equipment, 14 terawatt hours. So it is a significant part of the energy system, and a significant part, therefore, of the climate challenge that we have in Sweden. So what did we do? Well, a number of people, again, trying to look at this leadership and partnership, a number of very clever people at Volvo, construction equipment, and some of my colleagues, we sat together, what can we do? What would be the possibilities that we have? Let's try to be visionary, and let's to see what is the next step for your industry, and how can we contribute to that as an energy agency. We looked at one of these, and now we're getting into your field of expertise. Well, what would happen if we would use electrical power instead of diesel in this picture? What would happen? And let's look at some of the figures here. And we came out that if we could electrify a number of these functions, we would quite easily be able to sort of reduce energy use, calculated in kilowatt hours, with 71%. That's not CO2 emissions, but you can calculate that. And it, of course, depends where the electricity comes from. And in Sweden it comes from water or nuclear, and it's a different thing than what you would do that in Germany, where you would probably have most of it from coal. But anyway, the intensity of the energy is much higher with electricity. That's why the savings are potentially that high also. But if we look at this, and we started to identify a number of functions here that say, what would happen if? And landed together in a big demonstration project, where we, with researchers, with universities, together, will try to identify the next step for construction industry. So if we then, for example, here look at the excavators, for those places where they are quite sort of stable at a certain amount of time, we will be able to supply them with electricity via cables. The crushers in this quarry will be able to get their power through cables. We would be able to develop maybe plug-in hybrid solutions for loaders or haulers. And a really exciting aspect also is that if we would be able to develop dumpers, these big ones, I don't know if I use the right terms every time, they will be able to be fully electrified with batteries, being charged at different points, but also fully autonomous. Because that's what's great with these kinds of areas. They're closed off for public. And we've heard earlier from one of the researchers how a driver is the significant part in fuel use. If we would have fully autonomous, computer-directed dumpers, it will be a significant change also. Very exciting project, and we're from the agency go in with 65 million. We'll be able this way to cut CO2 emissions from, say, the regular 0.7 kilograms per ton material produced in these types of construction sites, these types of sites, to 0.03 kilograms. But it also has a significant potential to be applicable outside of just this quarry. You could use these types of machines and in larger construction sites, waste recovery sites. I mean, you know better. All these other sites where you use the types of equipment that you are constructing. Great potential, and we're very proud to be part of this this unique project, I'd say. And I hope you're with us in sort of making this a reality as the new step for the construction industry to get into. And I think I'll leave it there and maybe have some time for questions left.
Thank you very much, Erik. Have a seat here.